Hello. Today we're going to talk about Unit 9, Lesson 5, the zeros of a quadratic. So, the x locations of any function where the output of the y coordinate is equal to 0 are known, not surprisingly, as the zeros of the function. Okay. These are mainly important applied settings. When they are rational numbers, they can be found using a factoring technique. So we're talking about something we learned already. We'll develop the idea in the first exercise. So, what are the zeros of the function? So, write the x values and circle them on the graph. So what we do is I select to circle them, and it says that we also tell me what the x values are. So where are they located on the x-axis? So you have to start from the origin and just count. So the first one is left 1. So my x value is going to be -1. So you went left 1. And then you went right 3. So you have a positive 3. Those are my two x values. They didn't tell you write as a point, so it just told me to write them as x values. Verify that the positive 0 is correct by showing that y equals 0. So we're just going to focus on the positive answer. Okay? Focus on the positive answer. So just plug it in. So we're going to take the 3. We got y equals x squared minus 2x minus 3. We got y equals 3 squared minus 2 times 3 minus 3. If I did my math, we'll talk about it verbally. 3 squared comes out to be 9. 2 times 3 comes out to be 6. And we still have minus 3. If I did that, that would be 9 minus 6 is 3. 3 minus 3 is, this all comes out to be 0. So y equals 0. So we just verified. Verify means to prove that you're right. Now factor it. Now, to factor x squared minus 2x minus 3, we write down the number right here, 3. And we have to write down the factors of 3, which is 1 and 3. So all you have to do is figure out if it's true. So what this means is that we have a -3 means that you are subtracting your factors to be the 2. So if I factor it, you get x times x gives you x squared. You got 1 times 3 gives you 3. Now you need a positive and you need a negative. So which one has to be positive? The 1 and the 3 has to be negative, because if you did -3 plus 1 gives you a -2, and that's the number in the middle. That's your linear term. So, how do these factors compare to zeros? You got 1 and 3. What do you guys know? You got an answer, -1 and a +3. So, our job is to write down our answers for the following one. So if I wrote the next one down, so what you're going to say is that, somehow that happened, is that my two answers are where if I keep going, this is what we're going to try to get you guys to understand today. I'm just going to show you what it's going to look like. You get x plus 1 equals 0. If I move the 1 to the other side, it becomes what kind of 1? A -1. If I wrote down x minus 3 equals 0, and I circle the -3, what kind of 3 would that become? A +3. So those are the two answers that you would get. Remember, they're the opposites of what you have for factors. That's my son, just letting you know if you heard him. Alright, determines the zeros. So, if I took x squared plus 3x minus 10, wrote down 10, I got 1 and 10 gives you 10 if you multiplied, and 2 and 5 give you 10 if you multiply. Now, because it says to a subtraction of 10, that means you have to have a positive and negative, and that means the factors are going to be subtracting. So if I did that, I get x times x gives you x squared. I have 2 and 5 make 10, but they also subtract to be 3. So I need a positive 5 and a -2 to be 3. Now, I look at the table If I go to y equals, and I clear this out and put in x squared plus 3x minus 10, I would get, look at the table, I see that, if I can show it bigger, real quick, not that one, let's go to this one, alright, make it bigger, alright, so if I make it bigger, you're going to see that it's right here, negative 5 comma 0 and 2 comma 0. So if I go back and make it smaller, I have the opposites. So x would equal 2 and a negative 5. So basically what we're trying to get you to understand is that we're going to use the zero product law. If two or more quantities have a product of 0, then at least one of them must be equal to 0. In symbolic form, we got a times b equals 0. Either a equals 0, or b equals 0, or both are zeros. So here's the idea. I call it a t-chart. We're going to put two answers because we have two factors. We'll put x plus 7 could be 0, or the x minus 2 could be 0. Okay? So then we do the same rule we've been doing. We circle the 7, becomes what kind of 7? Negative 7. Circle the negative 2 becomes what kind of 2? Positive 2. Because when we move across the equal sign, it changes its sign. I do the same thing for the next one. X minus 4 equals 0. X plus 3 equals 0. So x would equal a positive 4. You circle that, becomes, and circle that becomes the next one. So x equals a negative 3. Those are my two answers. If you were to look at your calculator, you get the same answer as well. Now, zero product property in law remains remarkable because it allows us to solve equations with an x squared or higher level in it, as long as the expression set equal to 0 can be factored. Sometimes it can be factored. Right now we are. So find the roots in each of the following equations using the zero product law. So we have to set it equal to 0, which every single problem is, and we have to solve by factoring. So we have to practice this. I'm just going to add an extra step. So 12 gives you 1 and 12, 2 and 6, 3 and 4. So which ones subtract to be 4? That means x plus 6. So x and x gives you x squared. You got 2 and 6 make 12. If you multiply them, if you take or subtract them, you get 4. I need to have a positive 6 and a negative 2 to give me a positive 4 if you subtract them. So you get x minus 2 equals 0. Then you're going to put x plus 6 equals 0. So x equals a positive 2, and then x equals a negative 6 are my final answers. The square touches the x-axis. If I do the same thing for b, I'm going to do the same thing for b. They both are going to look at, it's not the same setup as a because this one's a binomial. So first thing I do, which I forgot to tell you in a, is look for the GCF. Right now I know they're both divided by 2 and they both have an x. So I take out 2x, then I divide each one by 2 and take away an x. So it just gives me x, because 2 divided by 2 is a 1. I don't have to put the 1 there, so I leave it out. Okay, so I'll put x, and then 14 divided by 2 is 7. So I'm going to put minus 7, and I don't need to take an x out, I don't need to write an x because I already took the x out. Then, since I have two factors that look slightly different than the first one, I still do both of them equal to 0. So 2x equals 0, and x minus 7 equals 0. This is where it goes slightly different for the very first one. Because it's timesing, I have to divide both sides by 2. So x equals 0 divided by 2 is always going to be 0. X minus 7 equals 0. So if I move the 7 on the other side, because there's no multiplication or division, I just move it to become a positive 7. those are my two answers. If I look at question number letter C, this one's probably the easiest one ever because it's a difference of squares. So because you have x times x gives you x squared, and 5 times 5 gives you 25, it has to be the same digits. You can get a plus 5 and a minus 5. If I do my t-chart, it's the same process every time after you factor. So then once you get the hang of it, it gets quicker. From a positive 5 to a negative 5. From a negative 5 to a positive 5. Those are my two spots where it touches the x-axis. Those are my two zeros. I'm trying to use the same vocab over and over again. Now this one seems a little bit harder until I go back and think about what I should always look for first. Is my GCF. Look at 3, 6, and 24. They're all divided by. Look at the smallest number, which is 3. Are they all divided by 3? Yes. So then I write down 3 first. Then I divide everything by 3. You get x squared. You can say 1x squared, but I'm just going to write down x squared. Minus 2x minus 8. Once you do that, I still have to factor what's inside. So I have to only think about this only. I don't worry about the 3 anymore. Just because I still have to have factors. So I need two sets of parentheses. I know that x times x gives me x squared. But I have to write down 8 again. I'm not worried about 24. 24 is out. 8 is what we're looking at because that's all we're looking at. That's the only thing I highlighted. I have 1 and 8, and 2 and 4. I know I have to do subtraction because that's a negative 8. So I need a positive and I need a negative. I just have to figure out which one goes in what spot. I know the 4 has to be negative because I have a negative 2. Because the bigger one has to be negative. Then I do my t-chart, but there are 3 answers because there's 1, 2, 3 factors. So if I put down 3 equals 0, that x plus 2 equals 0 and x minus 4 equals 0. If I'm thinking about it logically, 3 does not equal 0, so that's actually thrown out. We don't have to worry about that. It doesn't make any sense if there's no variable right there. If I wrote down x plus 2 equals 0, I know I have to move the 2 to the other side. It becomes a negative 2. If I wrote down my answer, x equals, I took the 4 and became what kind of 4? Positive 4. So there's still only 2 answers because the highest exponent is 2. So there should be only 2 answers. If you get 3, then that's wrong. So, next one. There's no GCF in each one of these. So I'm going to write down 30 because that's the last number we're talking about, the constant. 1 and 30 make 30, 2 and 15 make 30, and 3 and 10 make 30, and 4, nope, 5, yep, and 6. So this time they're adding. Which ones add to be 11? It's going to be 5 and 6. X times x gives me x squared. 5 times 6 gives me 30. 5 plus 6 gives me a positive 11. Yes. So now we do our t-chart. X plus 5 equals 0. So x equals a negative. X plus 6 equals 0. So x equals a negative 6. Last problem for just practicing. That's a quick one because it's a binomial and it's just, there's no GCF. I wrote down x times x gives you x squared. A positive times a negative gives me a negative. And 10 times 10 gives me 100. If you choose anything else for 100, it's wrong because that does not cancel out the linear term. If I talk about this, x plus 10 equals 0, so x equals a negative 10. X minus 10 equals 0, so x equals a positive 10. And the last part right here, we have to verify that they both have zeros. So if I talk about f of x is 1, we're going to set that equation. So I put f of x like this. we would take that equation and set it equal to 0. We're down 8, 1 and 8, 2 and 4. I know that I have to pick 2 and 4 because it says you have to add to be 6. So x times x, positive times a positive, gives you positive and a positive in the middle. 2 and 4, do my t-chart. So x equals a -2, x plus 4 equals 0, so x equals a -4. But I have to compare it with the other one. So, the way to compare it, I'm going to change the color so you guys can see the difference. We'll talk about g of x. Okay. I'm going to write down 3x squared plus 18x plus 24 equals 0. It looks different than the other one until I think about something. It's going to be at those numbers. Did I think about a GCF yet? Nope. But now I think about, wait, they're all divided by 3. Divide everything by 3, you should know that comes out to be x squared. That still comes out to be 6x. 24 divided by 3 comes out to be 8. Oh wait, they are the same. If I did this, I already did my work already. I don't have to think as much if I slow down and look. I get x times x gives me x squared. I get positive, positive, and I get 2 and 4. All because we have that set up. Now, it looks like we have 3 factors. So if I did my t-chart, if I did it over here, I get 3 of them. So 3 equals 0. Don't know. X plus 2 equals 0, and x plus 4 equals 0. So this one does not make any sense. So that was thrown out. This doesn't have a variable. Then it goes from a 2 to a -2. It goes from a 4 to a -4. And they are the same because it's exactly the same thing. Will the graphs look exactly the same? No, because they have something extra added to g of x. But will they touch where the x-axis at the same spot? Yes. Since they have the two zeros, are they the same function? You would say no, because they have different outputs. Okay, let's look at the picture. So let's go to y equals, let's compare. So you go x squared, let me see, x squared plus 6x plus 8 is one of them. Okay, then we got 3x squared plus 18x plus 24. And then we go and hit graph. Okay, so they have different outputs or different graphs. Okay. If they are the same function, is there a relationship between them? I say yes. They have the same zeros. What's another word for zeros is x-intercepts. Another word for that one is also roots. And then the last one, we need to know that they're all the same words, same, not words, but meaning is that solutions. Okay. So they're all the same solutions. So this is the answer for the first question. Okay. This right here is the answer for the second question. Okay. And then if I draw a picture real quick, I would say that if one's at a -5, -2, that would be the wider one. And then if I drew the other one like I do in my picture, I would do something more skinny. It's going to call, I wouldn't say the word skinny in math terms, we're going to say narrow. It's more narrow. Some people say the word narrower. I just don't like saying it. Well, hopefully this helps you out. This will help you with your homework. If you need a calculator, make sure you guys download one. And have a good day. Thank you. Bye.